a little background. Bob Basques here. I work for the City of St. Paul Public Works. Everything I'm going to show you is kind of geared towards the notion that we have a lot of records that have been collected over a lot of years, 100+ years, as a matter of fact, and a lot of it has been geolocated in some form. So my duties basically have centered around, for probably the last couple of decades anyway, keeping the data organized and making it accessible to everybody. There's a high kind of angle to grabbing the data for engineering purposes. So, public civil engineering side of things. And the idea there is that a lot of what we do is probably portable or convertible to other users. The systems have been built with the idea of using open processes and all those kinds of things. So in short, I've been doing this for a really long time. I think we've got some really good systems. I'm not trying to push anything on anybody, but take everything that you see with the idea that you can try and figure out how it would be applicable to anything that you're doing already as far as sharing data or needing to get at data that's shared, etc. It's very interesting watching the previous presentation how much overlap there's going to be in what you see here, at least in the first third of what I'm going to do. So there's kind of generally the idea here is I'm going to propose a model of operations, and this is what has worked for us very well for digital data sharing. It's from a municipal perspective, as I've already mentioned, and the majority of everything that you're going to see, with a couple exceptions, is built on open software and using open data methods for sharing. So the idea is that the data is freely available. I know that that doesn't work for everybody as far as organizations are concerned, but Public Works, for example, almost all of our data is made public. There's only a couple layers that we have that are kept under lock and key, and it's mostly for security reasons. All of the interoperability aspects that I'm going to show are built on those open and shareable processes. Everything currently functional can be packaged for mobile operations as well. I'll get into some more of that in more detail. But the whole system can be brought to the field, even the web services. So from the perspective of this audience right here, the previous presentation, everything that he was showing you on the screen, including all of the data behind the scenes that were populating the displays, in our system, it can actually be brought into the field in kind of one little small package. And I'll get into more detail on that. So I've broken up the presentation into three kind of sections. Basically, there's the now, what we're doing, currently, how we might be able to do some things better, and where the future is kind of going in my eyes. Again, this is from my perspective and where I see things being able to help us out in our field operations as far as ticketing goes, among a whole bunch of other stuff. I try to build systems that don't really kind of cater to one particular process. I try to leverage all of the development that we do so that it handles a majority of things. And product being that people have what they need. They're using it every day. They don't have to learn another application if possible. Everybody's seen this from the previous presentations. I adjusted it a little bit for our particular organization. All the dashed lines basically represent areas where our organization needs to improve. We're doing most of the things that are listed on this diagram, but dashed lines are where we need to kind of improve things. The reason that I put our version of that bottom blue square, which is the GIS database, that proposed public side, everything that I'm going to show you today is actually using our public server. So all of the data that you see is publicly available, and it's basically our version of that bottom blue square. The reason that I have it dashed is that not everything is out there. There's a couple of those layers that I was talking about that need to be set up in an authenticated environment. Right now, they actually are being managed separately for external access, but they're not kind of blended in with the system I'm going to show you yet. So in the now container of things that I wanted to talk about, this is basically our 2D kind of interface into things. Very similar to what you just saw in the previous presentation. Basically handles a lot of the data pieces that we have available. So we have a internal and an external set of this or installation of this particular access mechanism, this interface, and the data is copied between them dynamically every night. So it's kept up to date. Nothing's older than 24 hours. Our data management behind the scenes is distributed. And by that, I mean that each one of our data owners, and when I say owner, I'm talking right down to a specific data set. People that manage street signs, for example, they have their own data set. People that manage striping for the street, they have their own GIS data set. Each one of those data sets has got a person that's been assigned to that as a contact steward. In other words, a data set does not get published unless we have somebody that owns it and manages the data. So we need to be able to have mechanisms in this interface where they can actually send a message back to the data owner and say, this isn't right in this area. And the data owner manages the upkeep and all that kind of stuff. Because we have a distributed management system, we don't get into the innards of how they manage their data or even require how often they update it. They update it for their own reasons. In many cases, it's entirely up to them how they need to update it. There are some pieces of data that need to be updated a little bit more frequently than the originators thought because they're part of a longer pipeline. I'm not going to get into those details because we don't have enough time, but just throwing that out there is something else that needs to be thought about when you're trying to do this kind of a merged display. We log all of our edits and we can return to any previously edited state. This is kind of an interesting piece, and if you're into the nerdy side of it, we have all of our edits back to about 2007. And some of these edits are like done on a daily cycle. So all of those, I can return our data sets to any one of those previous points in the past. The interface is configurable for startup. What it displays, including those virtual fences that were remarked about in the previous presentation, you can actually set up the interface so that it only goes out and looks at a certain area with a certain set of layers on it. What I'm going to show you is basically showing you how we manage all of our data in one interface. The idea is to make it easy for people to look up in general, not knowing necessarily what data is available, but the idea that if they can look at a catalog, they can pull in what they think they might need. But the interface is set up with a configuration file where you can, here's the layers I want to see, here's the bounding area that I want to see, and it's all set up so that it can be initiated programmatically. So we can do exactly those kinds of things where you could bound it by a ticket. There's a component here of a large component in our interface related to document management. So the idea of what you're seeing on the screen there is actually a bunch of pages that have been geolocated for our survey section. There's about 250,000 of them. Took about 4 years or 4 man years to get this all geolocated. And what it is it's a scanned raster document of each page in all of the survey books back from 1898 or something like that. There's about 600 books that they had to scan and geolocate each page for. So all of these old survey records are available to anybody in the city as well as external commercial surveyors that use the system on a daily basis. The system contains about 300 layers. About 70 of them originate from within the city. The remaining are historical data sets. We've got a lot of aerial photos, for example. We have document link layers like I just described, and some of them are periodically harvested and cached locally. What that means is for performance reasons, we actually go out to other servers like neighboring counties, the state, some Fed sites, and we'll make a copy of their data so that we have a local version of it running internally so that we don't have to increase our bandwidth. This also applies to making that mobile version that I was talking about, and I'll get into that in the next section. So the harvest data includes all things like parcels from neighboring counties, all those kinds of things, aerials, traffic maps from the state. It's a proven system. The current version has been running since 2007. And when we put this system together, 2007 was when we open sourced the actual software that we use, that we built ourselves to run this. Some of the key takeaways here on this is that the data is stored and published online in a standardized way. So all of the data access is kind of standardized. The distributed editing and publishing system allows for uploading of various file types and database connections. So you can connect to Oracle or Postgres. You can also ingest shapefiles, geopackage. There's a whole bunch of the list is about 100 long. I'm not going to get into all of them, but the idea there is that we made it very flexible to load the data, and then when you access it, it's all standardized. There's also a coordinate transform. In other words, if the data is coming in different coordinate systems on the input, it's all output in a standardized way. And even when we're connecting to other systems, some of those connections are actually direct. We don't do any kind of caching. We just send you out to their system, pull their data back in, and transform it on the fly. So we'll get into a little bit of a demo of that. And so this is the interface. And again, everything that I'm going to show you here is available for anybody to access. So you can go in and do things fairly quickly. Remember, we're looking at about 300 layers in this catalog. There's a lot of information here. I mean, quite a bit of stuff. So you can see that there's a whole bunch of information in the available that we can look at in here. Just some stuff that I've been talking about so far. We can go into the survey section, and under the survey books, turn on the field books. You can see how many there are. I'm actually going to zoom in a little bit so we don't have so much of a dense coverage. And then you can activate the layer and hover over that, and then you have access to that particular page. So all documents that have been on this particular layer have been georeferenced in that manner. Now, there are other books layers here too, so we can turn on those other ones, and you can see that there's other information available, and we can make each one of those other layers active as well. I have to hold over the correct one. Oh, there we go. And they all have their own information available in a different form for clicking on as far as getting at the particular document. Now, I showed you how these pop-ups work for that particular layer, but we can also turn on information from another layer. I can turn on the traffic signs, for example, and make that active. And if I hold over one of those feature items, you can see that the pop-ups contain different information. The previous presentation kind of alluded to the fact that the data needed to be in a common schema, or didn't need to be in a common schema. Because of the way that we've addressed our distributed editing and management of the data, anybody can put anything into these information pop-ups that they want to. It's all running in a little fragment of HTML, and they can put anything that they want in there, including links to other systems. So for example, let me clear this out and redraw it, just so we get, we have a method to start over here. So what we can do is we have other systems that are available, and this is a document management system I'm going to talk about a little bit in further down. But the idea here is that we can georeference documents inside of this interface from other systems. So this is a particular document here that we want to look at. There's a bounding box of it, and you'll see that the pop-up information is completely different than the other ones that we saw. So the reason that I've got two blue bars there is I've got two assets. One of them is covering the whole city. So I have to be careful what I'm doing here, but this interface handles stacking of information. So I just got to make sure that I use the right one. But what it allows me to do is overlay a particular document in the right location based on the georeferencing that happened in the other system. And I'm actually going to show that other system as well. And it's another layer inside the information, and I can adjust the stacking and all those kinds of things. So, I talked a little bit about the open spatial data side of it and that cataloging access stuff. There's been a couple other presentations that you've seen that talked about WMS, which is a web mapping service, and there's another thing called a web feature service. Those are two kind of mainstays of how we publish our data to everybody outside the administration group. So the idea here is that everything that you see available in that cataloging system is available in one call, and this URL that you see here will actually output the XML that you see on the bottom there. Oops. Well, output the XML that you see on the bottom there and produce some kind of a, you can use it to produce a catalog like you see on the left. So the idea there is that all of that is configurable and machine readable. In other words, you can connect it easy to other systems. The mechanisms that we built on the whole have a very, very small footprint, and they're able to run on things that are very small for as a consequence. Because of the way that we've designed our system, we can run it on just about anything. So I was talking about that mobile data side of things. This is a computer about the size of a deck of cards, and it can actually run our server system. In other words, it can run all of the services that populate that mapping interface that I just showed you. I'm going to get into this a little bit more, but I'm just going to touch on that in the now, because the reason that I have this in the now section is we actually use 9 of these out in the field. So we've got these little computers like this actually fielded and are using them. We have been using them for a couple of years. Another piece of thing that's in the now that we're working on is publishing things with LiDAR data. And this kind of gets us to jump into the side of running things from 3D perspective. So everything I've shown you up to this point has been 2D. Now we're kind of jumping into the 3D side of things and making things a little bit more of looking at it from augmented reality side and virtual reality. So this is a LiDAR data set viewer that allows you to look at different things in different ways, and you can do different kinds of views of the data that's available. You can also stack data sets on top of each other. So over time, you could see changes in the data if you collect it appropriately. And the other piece of this, from our perspective at the city, is we need this stuff to be very accurately registered. The stuff that you're looking at here has a sub-centimeter accuracy. So if we get back to how that, the main diagram that we talked about earlier, and how everybody's kind of doing the work that they need to do outside, you can see how a lot of this stuff kind of fits together with that. We need to kind of figure out a way, especially from a municipal side, of how to connect our data circle of life. And what I mean by that is, once you build it, you have to throw that data back into your distribution process as well. And the idea is it goes back out for the next time they make something, and then it's built and it goes back into your system. Not everybody, and including our organization, has that complete circle of life established. But it's going to be something that's going to apply to everything that anybody wants to do with this distribution of data and keeping things updated. Data from construction and as-built moves to the GIS archives for that long-term access. That's what you're shooting for. You want to provide for better access to the data sets overall. In other words, make it as easy as possible. That's a reason that people will start using your system. It's why this one has been in place for so long, I think, is because it's very easy to get at the information that everybody wants. And then you publish your data in an open form where possible. I think that'll allow us to do a bunch of other stuff when we're able to do the publishing the way we want. Even though I've got a lot of this stuff on the outside, I've got it on the outside for our own reasons, which I'll show you here in a sec. But we're not really making it generally easy to find or discover by the general audience on the outside. We provide it basically for our CAD engineering side of the fence. So, but we can do things by like changing the data types and all that kind of stuff and making it easier for people to reuse it. So now we jump into the second section there and the better side of things. And what I wanted to mention is we've got this other application. This is that georeferencing piece of software that I was talking about. This is another open source piece of software that's available called MapWarper. And what it allows you to do is it's an online document georeferencer. You can batch load things in if you've got a lot of locational pieces like those survey sheets that we saw. You can put them into the system and batch load them and then just kind of store them there. And if you ever need to georeference them, you can go back and do that. So there are tools available to georeference the documents as needed. the way that this interface works is you just log in, and you're allowed to take the document, which is on the left side. That's actually the markup, their as-built document from the building of the new street alignment. And then the right side is actually a mapping system that you're going to snap it to. Now, I doubt if everybody in the audience can see it, but there are actually 3 little points of blue on the left side here that are being used to snap it into the 3 blue points on the right. And what that does is it basically snaps that particular document into the correct location based on those point locations. You can use as many points as you want. This particular document is only using 3. So we can jump into that. See if it loads. So this is our particular installation of that, what I just showed you as far as a, a Georeferencer tool. This is an online mechanism. So here's the document, and you can preview it inside the map. So there's the document overlaying on top of the map, and you can zoom in and out on this. And you can also go back and redo the rectification. So if you find that it's a little bit off, you can go back in here and adjust those points. And this is all done online. And you can also look at everything that has been done and uploaded. So these are all of the things that we've uploaded over time. And you can see that there's various different documents, and you can preview them inside the mapping system. So you can see that the document is georeferenced. This is all handled online, and the document management side of it is a big plus for the stuff that we're doing. So setting up the open catalogs, to the data for the users, and making the data available for machine-to-machine connections, that's my kind of crux. That's my kind of pet way that I put things together when I build systems. I like to make everything kind of as automated as possible for connecting up different applications to things. Providing the processes for accessing that data, that's where that WFS, WMS stuff comes into play. And our primary use for our data stores when we first built this was to provide the data for our CAD users and our CAD sessions. So our CAD software of choice is AutoCAD. There are other various ones that allow you to do similar things. But we have a little tool set that basically will replicate the catalog that you saw in our 2D interface. So all of the data that's available in that 2D interface is also available in here because we've set up all of those open data systems and made the interconnections work. So when I change something in that 2D master data set interface, it automatically appears in here because it's reading the same configuration file that's used to open up that interface and list out all of the layers that are available for loading into your application. So you can pull in any of the data sets from the online interface with the same catalog naming and everything that's available in the 2D interface right inside of the AutoCAD session. And you can do the stacking and all that kind of stuff as well. So I pulled in an aerial photo data set here, and then we can start pulling in all of our infrastructure items right inside the CAD session as well. The reason that I'm showing this piece of it is that this, it doesn't need to be an AutoCAD application that you're pulling this data into. It can be anything like an application that runs on a phone, for example, because of the way the system is set up. All of the data set is available to whatever client wants to be able to utilize it and display it. AutoCAD is our primary target, but it can be any number of these commercially available apps. Since the access is all web-based, any other web mapping system can access the data as well. So anything that can go and request something off the web can pull the data into their client of choice or application of choice. Another piece of the equation here is I kind of got in a little ahead of things here, but we can pull in some stuff related to the 3D side of things. So I haven't really jumped into that yet, but the point of this is that you can pull in the 3D data as well. And we'll jump into there and see how that works. So what we can do Again, all of this stuff is available on the outside. So this is the 3D interface that I've been kind of mentioning here and there. And where this is going is the idea is that we're using a very similar system, but this particular interface is in 3D. And it's able to manage the data handling capabilities all automatically. Basically, this is showing some LiDAR data, billions of points in the data set, but it only downloads what it needs to be able to do its job. One of the other pieces of this is that, and this is, again, this is an open source piece of software. What we've done is added a catalog of all of our available LiDAR data sets. So we can, well, I'm jumping ahead of myself. So by default, there's 2 data sets that are turned on. These are basically coverages for the state that are available. So this one here is available at the state level. We've only got a little metro area chunk of it loaded, mostly because I don't have enough storage in my local storage to do anything beyond that. Not my problem, it's our central OTC. It's easy to do. It's not that we can't do it. It's just I have a hard time getting other folks to agree with me. But having said that, the idea here is that we can mix the data from our own data sets that we've collected. For example, if I click on a data set there, it actually adds it into the interface here. Remember, everything's in coordinates, and it's very highly registered to survey coordinates as far as construction needs and those things go. So I can mix and match these 2 different data sets. So now I'm just looking at the bridge data set itself, and you can see that those are all my control points, and I have mechanisms to turn those on and off. All right, there's a reason why I'm showing this particular interface and how it works. The other piece of it too is that this data is very, very accurately registered, in that you can actually, you know, count the brick lines and that kind of thing in the structures. So the data is very, very accurate and comprehensive. So why is all of this stuff important? These same processes and data publishing services can be used for other visualizers. I'm just showing you what we're using it for. That LiDAR data that I just showed you basically has a great big storage mechanism, I guess you'd say, or a better way to say it would be a storage schema behind the scenes that's running things, and that's really what makes it all work. The visualizers are just taking that data because it's in an open form. They can ingest it very simply and be able to display it. So the now can be leveraged for the future stuff. Remember, I talked about that small computer. It's called a Raspberry Pi, if you've never heard of them. Like I say, they're about the size of a deck of cards. And the reason that we were using them is basically, when we started to use them, was to put that, basically that 2D interface in the hands of our field operators. A lot of them needed to be able to get at a lot of the documents that I showed. I just scratched the surface on what I showed you. We've got probably about 300,000 documents available in there. You can actually fit it all onto this little computer and take the computer out into the field. It broadcasts its own Wi-Fi, and whatever device you have out in the field, which could be a phone, a laptop, a tablet, anything that can connect up to a Wi-Fi can connect up to this device and is able to display the same interface that I just showed you in the 2D interfaces. The 3D stuff that I just showed you is also possible to put on there. We're not using that yet. I'm going to get out and say that, but the interface that we're using is very similar to in size and footprint to what we were doing for the 2D interface. So the 3D stuff, the LiDAR, can actually be put on this as well. The way that it works for us is that you basically have a switch on it. All you do is turn it on. There's no more power. You don't need to know anything else about it. You turn it on and keep it in proximity to anything else that needs to connect up to it over Wi-Fi. When you bring it back into the city offices, whenever you're within the network and it can connect up to our internal Wi-Fi, all you do is just turn it on and it'll automatically go back to the server, and there's a display on our billboard that we have that'll tell you that the thing is being updated. And it takes a few minutes, like 4 or 5 minutes for it to update. And what it'll do is it'll check all the data sets back and forth, which could be done basically on that virtual fence line or a ticketing basis if you needed to, or by organization, however you needed to do it. All of that filtering can happen on the fly. And the idea there is that you just, when it's done, the display will tell you that it's done and completed. You just turn it off, take it back out in the field and turn it on. These things are so low power requirement as well, you can actually put a battery on them that's rechargeable and they last all day. So you can just hook up to it, you just leave it in your pocket or clip it onto your visor in your vehicle. So you can take everything in the field, deck of cards, we automatically sync them in the office. One of the pieces there that's interesting is they're as cheap as $35. The newer versions now are getting a little bit up there, they're about 75 bucks. But for $100, you can have one of these things, and I mean, it's all, the cost is like at a throwaway level. You can just take these things and throw them away. They're that cheap now, and they work very well. I can demonstrate these things. Again, we've got about 8 or 9 of them in the field right now. Some for our survey section and some for our traffic maintenance night crews, or lighting maintenance night crews. There's also a keyboard option. In other words, the computer is actually built right into the keyboard, so all you need is a display. So this is a Raspberry Pi 400. The idea there is that all you need is a display, so you can just put a display up in a vehicle or something like that. The Raspberry Pi is right in here, so you can do some other things with that. We haven't really messed with this yet, but it's another option. So one thing I wanted to talk about how all of this can come together is that you can see in some of these videos that I'm going to show here, I'm just going to talk over them as they go, where a lot of this kind of stuff can pull together. So what you're looking at here is a video of a 3D model overlaying on top of the camera feed in a phone. Because the model is registered very tightly out in the field to known objects, you can actually see the underground utilities where they actually are underground. So what it's actually showing you there is he's able to fade the information in and out and show the information that underground. I'm gonna jump around to a few of these because I've got a couple of them, and I don't want to spend too much time on them. But these are different examples of the same kind of mechanisms. So the LiDAR data that I just showed you, there's no reason why we couldn't be collecting that data. And this is a new form here, but it's going to be dependent on how the data is collected out in the field. But where I want to go with this is to use these data sets as basically your inspection record of when you go out there and actually look at things before it's buried. So the idea would be that you would scan these things, and you can scan them with handheld scanners now very quickly. The stuff that you're looking at here was actually assembled from photos that were taken in sequence as the recorder just walked down the street. So they just took a series of photos, and then those photos were used to build a 3D model from. It's not quite as accurate as LiDAR, but it is workable, and you can see the results right here of how it works. So my thought here is that if you put the device and oriented it correctly, there's no reason why you couldn't just kind of walk along and see everything that's right underneath you. There's obviously other methods that I can't even think about of how you could use something like this out in the field for marking. But you can certainly see that it's going to tell you a lot of information and beyond what is currently available in the field, or at least generally available currently. But this is kind of that futures aspect of things, and it's the side that I think we need to consider pursuing as well. So all three of these topic points kind of need to be progressed in a parallel fashion. I mean, that's kind of the way that I would approach it or advise on it. And the idea is that you build out your base systems, that all the now stuff that I described. And then you also have this better or improvement plan. And then there's this future or innovation side of the equation. And all three of those need to be kind of progressed at the same time. And the reason that I would say that is that's how you effectively kind of keep everything up to date and moving forward and adding technology and all that kind of stuff. You have the infrastructure in place to do that. I threw this on as a kind of a resource list, everything that I've shown, and I'll just leave that up there for now, but I'm done. Any questions?
Bob, Barb here. How much of the underground utilities in St. Paul are mapped?
Everything. I have all of my sewers. I didn't really get into the specifics of what we have available, but I have all of our storm sewers, all of our sanitary, all of our cabling for our lighting. I actually have data available from different utilities, but I'm not, because of our agreements with them, I'm not allowed to generally make it available, but we use it for engineering purposes. And we can connect to their services where and if we need to. One of the problems with that is we don't get the data updated very frequently. And you know, like I do, that stuff changes daily. So having that stuff updated regularly is my big deal, and why I like to make the machine connections where possible.
Do we have any more questions? Okay, going once, going twice. Gone. Well, Bob, thank you very much for sharing those insights with us. I think that was particularly coming on the back of the Scottish Vault thing, a combined vision of potential of where we can go with things. So thank you very much.
Yeah, it was very interesting to me that a lot of it overlapped the way it did.
Yep.
Yeah. Thank you, Bob.